Let's look at a simple example for a linear scaling system. The system is defined as follows. The output y of t is alpha times x of t, where x of t is the input. Alpha here is an arbitrary complex valued constant. Okay, so this is the test of linearity. We feed in signals x1 and x2 separately through the system t, and inspect an arbitrary linear combination of these two signals. Here, c1 and c2 are arbitrary constants. We then compare a linear combination of x1 and x2 fed into a single system. In order for the system to be linear, the left-hand side needs to be equivalent to the right-hand side of the equation. The left-hand side evaluates to this, as the system just applies a constant scaling by alpha. And the right-hand side applies a scaling alpha to the linear combination of these inputs. And it's quite obvious that these two are equivalent, which means that this system is linear. Okay, let's look at the test for time invariance. Here's the formal test for time invariance. T is the system and D is an arbitrary time shift. This means that we can apply a time shift before or after applying the system T, and we will get the same results. Let's evaluate first the time shift operator D on the left-hand side, which results in x t plus tau, a time shifted version of the input. And now let's evaluate the system definition on the right-hand side first. Now we're left with the outermost systems. On the left-hand side we have the system definition T, and on the right-hand side we have a time shift D. Now if we apply the system on the left, we get alpha times x t plus tau, and on the right-hand side we get the same. This implies that this system is time invariant. Alright, this concludes that the scaling system is a linear time invariant system.